Okay, this is the second podcast about atomic radius, or talking about size of the atoms. In this case, we're going to talk about the size of ions, what happens when an element loses or gains an electron. So size is going to, this is an overall graph showing what happens to both the atom and the ion, okay? So ion size is going to depend on the nuclear charge, right? That's where the positive charge comes from. The number of electrons and the orbitals where they reside. So let's take a look. So let's think about cations. Remember, cations are positive, right? So they're going to be the positive ions, and an atom becomes a cation when it loses an electron. And when it does that, it's going to lose whatever is in its outer shell. So what happens is lithium has one electron in its outer shell. It loses that whole shell when it becomes an ion, and that's what makes it smaller. It's like losing a layer of the onion. Okay, so here we have this would not be lithium. This would be beryllium. I'm sorry, it is lithium. It's got these two inner electrons. It's got one outer electron. When it becomes an ion, it loses that entire outer shell and becomes smaller. So let's take a look at anions, which are the negative ions. An anion, or an atom, when it gains an electron, actually becomes bigger. Okay, so a chlorine adds an electron, becomes bigger. So let's talk about why that is. So it's not quite as intuitive as the cation, but so here we have chlorine. It's got 7 valence electrons. When we add an electron, now it has 8 electrons in its outer shell. So it's got the same number, they both have the same number of protons, right? 17 protons. And this has one more electron. And what happens is, the distance away is pretty much the same number of energy levels. But now I have an 8th electron. And what we said earlier was that if I have multiple electrons, because they're both negative, they're going to repel each other a little bit. And that's what's happening here. The more electrons I add, the more repulsion I have between them, and therefore the further apart they become. Okay? So as I become an anion, as I add electrons, I increase repulsions, and repulsions cause the atom to become bigger. Okay. So if I just compare ions from a group, within a group, lithium plus 1 versus sodium plus 1, same thing as with an atom. I'm adding energy levels as I go down, so they're going to get bigger. Okay. The other thing we want to talk about is this whole idea of an isoelectronic series. So an isoelectronic series is one where the let me see. The definition is on this next page. Is one where the ions have the same number of electrons and energy levels. So if I think about this, and let's skip ahead actually to another diagram that I think will be helpful to think about this. So if sodium is losing an electron, it is becoming like neon, right? The noble gas neon. It loses that outer shell. If magnesium loses its 2 electron, it also becomes like neon. If aluminum loses its 3 electron, it also becomes like neon. Likewise, if fluorine adds an electron, it also becomes like neon. Oxygen gains 2 electrons, becomes like neon. Nitrogen gains 3 electrons, it becomes like neon. So here I end up with all of these and neon ending up with the same exact configuration as neon. So let's think about what we have, right? In all cases, we have the same number of shells and the same number of electrons. The only thing that changes is I now have more protons in the center as I go from nitrogen through helium and then sodium through aluminum. Okay, so let's take a look at the trends. So in an isoelectronic series, the size is going to get smaller with increasing nuclear charge. They all have the same number of electrons. They all have the same number of shells. The only thing that's different is I have more protons as my atomic number increases, right? So I'm going to create more pull from the nucleus with that electron that has a higher atomic number. Okay, so let's see if we can answer a couple questions. The first is, which is going to be larger, a sodium plus or a sodium? Think about it and answer. Okay, so if you said sodium is going to be bigger, you were right, and that's because both have the same number of protons, but sodium has one more energy level, right? It loses that energy level when it becomes an ion. How about chlorine? Which is going to be larger, the chlorine minus or the chlorine atom? Think about it. Okay, so if you said the chlorine negative is going to be larger, you were right, because remember, we're adding more electrons, which is increasing the repulsion, causing them to be further apart, and therefore the ion becomes bigger. All right, that's going to do it for us on ion charges or sizes.